Ag Tire Talks Driving Yield Through Tire Technology, sponsored by Michelin Agriculture.
James Tushner with Ag Tire Talk here. I'm with Mike Gelbman from Galileo Cupwheel. We're here to talk today about an interesting, really an innovative product offering. We've seen the tracks gain in momentum, and this particular tire really works with the same concept as a track. So I'll hand it to you, Mike. Why don't you give us a dissertation on really what this unique offering is and really what it has to offer producers?
Okay, thanks first of all for having me. Pleasure to be here.
Absolutely.
Um, Galileo Cup Wheel is at its core uh, I use the term revolutionary, but it's a quite extreme innovation in the tire industry,
It's
such as
different.
hadn't really been seen since the radial tire,
Amen.
since the advent of the radial tire. We believe ours is the next step, and as you know, radial tires came out a long time ago, so
So
it's
let's,
exciting. The cup wheel was invented by an industrial design student who is still with us today. He's our chief technology officer. His name's Avishai. A number of customers in Europe and US know him because he's been at it for quite a while.
I've
Uh,
seen him.
Galileo Cup Galileo Cup Wheel's been around for longer than people realize. A good over a decade, really.
Uh-huh.
Um, but we took the innovation that Avishai created and got a patent for eventually by basically playing around with the paper cup. And a project that he had in school, in design school, was to come up with something that rolled perfectly round. And as he was doing that, and he was rolling a paper cup around, he realized that if he put the wide sides together, it wouldn't roll straight. But if he connected two of them, it would roll straight. And then if he
Uh-huh.
cut them with scissors into a mesh like a gearbox and put them together, it would roll perfectly straight. That sounds a little crazy, but that evolved in today what is the cup wheel and the design for manufacturing a pneumatic tire that literally works like a track. In a
It's really
nutshell.
interesting, just from an analogy standpoint. If you take your old school Dixie cup and you put it on your desk, right? If
Right.
you just put a little pressure on it, it smushes down. Really, that's the concept. Am I right, Mike? It
That
just
is
really
that you
the
got it. It flattens it out and it makes it roll in an oblong type, not a perfectly round manner. And that's you're changing the deformation, the way the
yeah,
tire deforms.
it's so cool really to see in action. It's not about the width, it's about the length. And
Correct.
really, it substantially elongates that length, right? Which, of
That's
course,
right.
is a very big deal in the soil compaction piece. Before we get on to, really the differentiations between standard pneumatic and really what it can mean for a producer, I first want to tee up really the imagery on it and talk about really what that sidewall looks like. It's so different. Give us a visual on that, Mike.
Yeah, so our tires immediately when you look at the side from the sidewall from the side, you see something very different about the Galileo tire. It's got a concave sidewall. I mean, it just anybody can see that there's something very strange looking about this tire.
Yeah, it's
So
inverted.
traditional tire design is to have sidewalls that bulge outward,
Uh-huh.
that deform outwards from the center of the tire. Tires are basically air chambers, and the radial tire flexes more, and the more progressive, uh, technologically progressive tires of today in the agricultural world, the IFVF tires, flex an incredible amount, and they can take more air pressure and they can carry more weight. These all use the same method of bulging out. The wider tires get, the more footprint you have, the more flotation you have. We've changed that literally. Just we have no sidewall. There's no bulge. It's concave, so it
Inverted.
deflects
Amen.
inward and inverted. Right, inverted actually probably the better word. And it deforms all to length, a completely elongated footprint, and that's what gives us the characteristics of a track on the ground. And it's superior flotation and lateral stability, which has caught the attention of a lot of OEs and farmers in the agricultural industry and the construction industry as well.
Yeah, before we get on to the detail of the footprint, one last thing. Really, the tread designs from what I've seen, they're pretty much traditional. It's really all
That's
about the elongation of the footprint. Is that right?
That's right. Not to take away from the importance of the of tread patterns and tread
Cheers.
designs.
Yep.
Obviously, they're important, but they're not as important in our tire as they are in traditional tires. That's correct, because it's the shape of the tire, the contour of the tire that's actually giving all the benefits. So obviously, we need traction. You need something for agricultural that does um, provide some traction for us, but it's less critical for us than it is in standard tires.
Yeah, if anything, it's really a supersized elongation of the footprint. I mean, to the tune of stuff that you've never seen. I highly encourage you to check out the visuals that we'll have associated with this podcast. Now, let's get to some specifics. So, what's the diff, man? What is the difference between just a standard, let's just stay on irrigation. We got 11,238 footprint X flat plate to Y. So give me some idea of what kind of a difference just in footprint we're talking about.
So it's safer to talk in percentages because there's so many different
And that's
tires, and
yeah,
there's also
that's
and
cool.
there's also size differences, but there's also air pressure, load capacity, load differences, and air pressure differences. Um, our irrigation, now we make both pneumatic and airless tires. Our
That's
our
the next
shape
point.
allows us to go both ways. So we've designed the irrigation product, as you know, to be 100% airless.
Perfect.
Um, our other our agricultural track, our basic tractor sizes that were brought out beginning in Europe are actually pneumatic and very low pressure, but they're not airless. So the irrigation tire um, is we've seen over 30% more surface contact than standard
About a
conventional
third.
pneumatic
Very
tires.
nice.
And
Awesome.
again, that's all to length, not to width.
And it
That's
looks
100%.
it.
Yeah.
I mean, I'm looking at
So
the visual going, wow, yes.
so we have a very, very long footprint, and that's again, that's what gives us the property, the characteristics of a track as it moves along the ground. That increase in surface contact is just phenomenal. And on pivot on irrigation pivots, you need the flotation to get through the mud. I mean, irrigation is all about irrigating, so soil gets wet, and a lot of these fields are in uneven areas and they have drainage issues, and they just really get. You've seen them, I'm sure. I mean, you get into over halfway up the wheel well, and
Yeah, I've seen them
many
have big
tires just
problems.
don't. You just can't get through there. So we actually solve that problem. I can get into a lot of other benefits as well, but that elongation of the footprint gives us the flotation that's like a track.
Yeah, and I've seen it now that it can be side by side on traditional stuff, and this thing just has enough flotation to keep on rolling and not get stuck. It's a really big deal. We really focused on the sole compaction. One thing we didn't touch upon, it is airless. So really, we're talking about virtually no downtime. Why don't you give the dissertation on that feature and benefit of the cup wheel?
So so any farmer that uses pivot or lineal, center pivot or linear irrigation systems, one of their great nightmares is having that pivot or linear down whenever, and it's when they're watering and they're at full flow and in the middle of, the loss in productivity, not to mention the labor involved, the downtime is just phenomenal. And we've actually done a recent study. I can throw some numbers up a bit later into this if you like, but the costs are measured in loss, not just in the labor, but in the loss of yield. When you're getting stuck each rotation in that certain place, and a lot of the farmers have to take a skid steer or a
Oh,
telehandler or something
what a
out there,
mess.
or maybe just an ATV, but they're usually not strong enough to pull it through that boggy area. They build bridges
Yes.
sometimes. I've got pictures of some of our customers that built bridges to so these tires can like ride over that muddy spot. It's just a horrendous problem, and these irrigation systems, as you know, are pretty high tech these days. They got GPS that use algorithms for steering. It's incredible. They got weather systems. They got cameras that show the farmer the moisture levels at different parts of the field, where to water more, where to water less. It's phenomenal how exact, how precise they are. And
Yep.
one of the great problems left is that, tires going down. It keeps the machine from being totally autonomous. Farmers are operating these things from apps in their phone from the kitchen table. As you know, they can turn them on, turn them off, reverse direction, and having that tire be completely hands-free it makes that system completely autonomous finally.
It really is unique. And really, I mean, just looking at it from afar, just focusing on the irrigation, really, I don't see a foot. It's got to be I haven't seen, it's got to be the largest footprint that I've ever seen. It is the largest footprint that I've ever
Ab-
seen.
Absolutely, yeah, yeah.
Bottom line, largest footprint, you're going to get that flotation, and then airless. Your downtime is down to none. You don't have to worry about that, air loss situation. Really, a very innovative product. Really encourage you to even do some further research on it and check out our visuals. And that's a wrap.
For more information, Galileo's toll-free number 888-280-0851 or email info@galileowheel.com, and the website is www.galileowheel.com.